Just wait for a few minutes. We are starting a YouTube live stream. Then we can start the session. Due to there's a huge rainfall here. I'm in a different state. Due to heavy rainfall today, we are unable to conduct the session at 3:15. So while I'm just doing this on the background, can someone in the meet can just summarize what have we learnt in the past few days? Can someone just summarize, just in a nutshell, only the concepts? Anyone? Can anyone just summarize what we have learnt? Shikarani, can you just summarize what we have learnt till the last session, or else Sri Krishna? Just anyone. You can just unmute yourself and you can just summarize it. Not in detail, just the topic name, what we have learnt.
You mean from the day one?
Yeah,
Okay, I'll try to do it. Basically, it started with discussing about the track width of copper traces on the circuit board, which depends upon the current flowing and the temperature and thickness. And on the second, you thought about as the manufacturing process of the PCB, which includes the, designing the PCB, photoresist, photomask, Gerber files, and the fire retardant, etching process, still screen, and the different types and manufacturing of still screens, solider mask, and you derived about the equation which is required. And you also discussed about the various epoxy layered inks, non-conductive, different types of capacitors such as the polarized and the non-polarized ones, and two colors of the silk screen, which is the standard and the colorful layers, and manufacturing process like liquid photoimaging, direct resin printing,
right. Yeah,
and then you talk about resins.
right.
Easy EDA, like the options in ECDA, we use how to create a file and how to place the resistors, capacitors, grounds, connection, and layers in different types, top and the bottom in every layer, like copper layer, inner silk screen layer, stencil layer, assembly board outline, and then you discussed about the NC flag, short flag,
Yeah,
and
net labels.
yeah, net labels and the decoupling capacitors. In the previous session, you discussed about the BMP280 schematics and why they needs to be connected to VCC or some power supply, and pull up, pull down resistors and current limiting resistors.
Yeah. So we have also discussed a few insights like how to choose a component, not only based on its size or based on its type, right? We need to take the current parameters also. So last in the last session, we someone posted, I don't remember. So someone posted two different voltage regulators, and we have made a comparison between them. So depending upon the current requirements, one is like having the maximum current, it is rated for 300 milliamps, and another is like it can deliver up to 800 to 1 amps, 1 amp of current. So based on the current requirements, we need to choose the component, right? So these are the things we discussed in the previous session. So this time, last time, Sri Krishna has shared his screen. Now Shikarani, if you are free, like you can start sharing the screen. So everyone is ready with your BMP 280, right? Everyone is ready with your BMP 280 circuits, right?
Yes, sir.
Okay, so Teja Anirudh, if you are on PC, you can start sharing the screen. Yes, Teja Anirudh, are you sharing your screen?
Yes, sir.
Yeah, yeah. Please do it. Please do it fast. The session is being delayed. Okay, fine. So there are few people who even don't know about the BMP 280 schematics. So Teja, Anirudh, just explain them. The connections. What are the different connections that you made in the BMP 280 in a glance? So there are few people who missed the previous lab session. Can you just explain the schematics, like what are the components you used?
Yes. Here we have used two capacitors and two resistors.
Okay, so
And
those two capacitors, wait a second, those two capacitors are called as the decoupling capacitors. The main
yes, sir.
purpose of the decoupling capacitors is to filter the noise, okay, input supply noise. Yeah, so
Yes, sir.
always decoupling capacitors are placed very closer to the power rails, input power rails. That I mean, they line very close to the VCC. Okay, and then we have the main IC BMP280 IC, which he placed, and then there is serial clock and serial data lines. Can you just magnify them? Serial clock and serial data. Yeah. So there, those are called serial clock and SCK means serial clock and SDI means serial data. So every IC will have two different rails. One is like a power rail. Yeah. So one is like a power rail and the another one is data transmission rail. Okay, data transmission rails. So there are two different rails, power transmission, because every IC require a power itself to operate, and then it can transmit data, certain data to the microcontroller, and so that is serial clock and serial data. With the help of these serial clock and serial data lines, data will get transmitted. And then we have CSB means chip select. Okay, we are not going in detail what exactly these things are. So we discussed that there is a pin called SD0, right? SDO, serial. So can you just show that? Yeah, SDO or SD0, both are same. So this pin is can be either connected to ground or it can be either connected to VCC. So can you just tell me when Teja Anirudh, when we connect it to the ground and when we connect it to the VCC? So there are two conditions, right? So SD0 can be SDO can be connected either to the with the ground or it can be connected with the VCC also.
Yes.
Yeah, do you remember those conditions?
No.
Okay, fine. So there are actually every microcontroller can have multiple sensors, right? This is the BMP280 sensor schematic, barometric pressure sensor. So like this, we can have multiple sensors also. So the microcontroller is able to differentiate whether the data which is coming to it is from let's say sensor A or sensor B. It is able to differentiate only with the help of something called an I square C address. Every sensor carries I square C address. So only with the help of whenever the information is exchanged from a sensor to a microcontroller, along with that, initially I square C related configurations first get exchanged, like the I square C address, the bit, it will be transmitted in the form of bits. So immediately the microcontroller can understand whether the data is being sent by a sensor A or sensor B. It can able to distinguish between that. So every sensor will have I square C address. So few sensors can have multiple I square C addresses. Let's say BMP280, it can have two different I square C addresses, 0 into 77 and 0 into 76. By default, it is set to 0 into 77. Okay. If it is connected to ground, it is set to 0 into 77. Or else if you want to override it, the default I square C address, you want to change it to some other I square C address, you can set it by connecting it to VCC. If you set the pin SDO to high, the I square C address will be changed from the default configuration to the alternative I square C address, which is 0 into 76. Okay, so this is the thing that we discussed yesterday, and we also discussed that what's the necessity to have multiple I square C addresses for a single sensor. So if we are having same kind of sensor, let's say we are having two different BMP280s with us, so both are having same I square C address, right? 0 into 77. So unless you don't have an option to fall back to some other alternative I square C address, the microcontroller may not be able to differentiate whether the data coming to it is from the sensor A or sensor B, because the I square C addresses are same. So we call it as I square C address conflict issue. Okay, so to resolve this, the manufacturers are providing a fallback I square C address also. For one sensor, you can set it to 0 into 77 by connecting the SDO pin to high, so by connecting it to ground. And for the another BMP280, let's say BMP280, the second one, you can connect the SDO pin to high. so that it can set the I square C configuration as 0 into 76. So for one we are having 0 into 77 and the another we are having 0 into 76. So no I square C address conflict issues. Okay, so this is the thing we discussed yesterday, and we also discussed one more thing that so if we want to place multiple, let's say 5 or 6 BMP 280s, so here we are having a limiting factor, right? The limiting factor is like we are having only two I square C addresses. Only two I square C addresses are possible, either 0 into 77 or 0 into 76. So for one, let's say you are having 5 BMP280s must be connected with a single microcontroller. For one, you can set 0 into 77. For another, you can set 0 into 76. Still, we are left with three more BMP280s. So you have no option, right? Even though you set it to 0 into 77 or 0 into 76, it will cause a I square C address conflicting issue, because already we are having an another sensor BMP280 module with the same address, so you cannot specify the same address for them. So that's why to resolve this issue we are having something called muxes. Mux means multiplexer. So there are two different things called, one is multiplexer and another one is demultiplexer. So these muxes can resolve the issue. With the help of multiplexers you can solve the issue. You can operate multiple uh, modules even though they are having the same I square C addresses. Okay, so these are the things that we discussed yesterday. So today we will be discussing about plated vias and non-plated vias. Okay. So yeah, can just open a new browser window and you just search for via, plated via and non-plated via.
New project.
No, no, no. I'm just asking you to open your browser.
What should I say?
I think you are sharing only that particular window. Come back to Google Meet and share entire screen. Yeah, now just
Yeah,
search
now
for
just search
plated via.
plated via.
And one more
And one
request,
more request,
again come back to
again come
Google
back to
Meet.
Google.
While you are
While
sharing
you
the
are
window,
sharing
there
the
will
window,
be option
the
called
option called
share audio
share
also
audio
just
also
below the window.
to the
Just
window.
disable that.
Disable that.
Stop share
Stop
and come
share
back to
and come
Google
back
Meet.
to Google
Again
Meet.
start
Again
sharing the
start
screen.
sharing
There
the
will be
screen. There
option
will be
called
option called
disable audio.
disable audio. Sure, I have one down.
Yeah.
Yeah. During the
Yes.
yes
Schematics of
schematics of
BMP2.
BMP2.
Okay,
Okay,
Teja, can you
Teja,
please stop sharing the
stop
screen?
sharing
I'm
the
hearing
screen.
an
I'm
echo
hearing
here.
an echo
I
here.
think
I think
you are enabling
you
the
are
audio
enabling the
option.
audio option.
Yeah, Sri Krishna. What's your question?
During the preparation of BMP 280 schematics, you have
Yes.
added multiple resistors, inductor, and an LED for suppressing the noise signals and for protectiveness. Right?
Right.
Is there a limit count that we should add only these number of elements to the circuit, or we can add as many as possible?
There is no such restriction that you need to add these many components only. But if you go into deep, there will be a restriction that the overall impedance we need to take that into consideration. For every schematic, there like for every sensor there would be a maximum allowed impedance, right? So if you go beyond that, the system may not work. So you need to make sure like the overall capacitance, overall impedance of the circuit should be within the range. So these things you can find in the man data sheet as well. As we discussed in the earlier session, these things you can find in the data sheet. What should be the overall impedance and all these stuff. So basically, you can add as many as components. You can add protectory circuits. You can add a fuse. You can add metal, ESD protection, electrostatic discharge protections, and something like metal oxide varistor. These are the protectory components. You can add them if you want. And an inductor, it is also there. In even there are few filters, right? So in your while you are studying in your BTech in the upcoming when standards you will get to know there are different kinds of filters. So you can use those kinds of filters as well, filter
Like
circuits.
RC, RL, RLC circuit filters,
Yeah,
right?
something like that. Combination of basically they are the combination of capacitors and inductors only. They are used to filter the power supply. Yeah. So anyone having any other questions from the previous sessions? So today we'll be discussing about vias. So vias are holes. Okay, they are drilled through a PCB, and they are basically classified into two different types. The first one is a plated via, and the second one is non-plated via. Okay, so vias are basically they are the holes which are drilled through a PCB. So plated vias they are simply they are also called as PTH. PTH. PTH means plated through hole. Okay, and the second one is NPTH, non-plated through hole. The first one is plated vias or PTH, plated through hole. All three terminology is same: plated via, PTH, plated through hole. And the second one is non-plated via or NPTH, non-plated through hole. So they are basically two different kinds of holes. Okay, these are drilled on a PCB. And coming to plated via or else PTH, they are having copper barrel conductors. Okay, plated wires having copper barrel conductor. That means they are having a copper layer, just a hole, but having a copper layer throughout its circle. And then the second one is non-plated via or else NPTH, non-plated through hole. They do not have any kind of a copper layer. So when we drill a hole in a PCB, if you add a copper layer throughout the drill, we call it as the plated via hole. If you do not add any such kind of copper thing, if it's just empty, then you call it as the non-plated through hole. Okay. So based on the copper layer on the drill, you are classifying it into two different types. If it is having the copper, it's a plated via. If it is not having any kind of copper, then we call it as the non-plated through hole. So now today we will see about layout design also. So I hope all you guys are ready with your BMP 280 schematics. No problem. Even if you do not have your schematics ready with you, you can just listen to the session. So till today we have worked on schematics, right? We have learned so many interesting things, starting from the track with the derivation formula, all the way up to different kinds of things like different strategies. Like we learned about I I square C addresses, right? So today we will be introducing the layout design window with you. Till today you guys have worked on schematic design. So today we are introducing layout design tool with you. Okay, so for that I'm just showing you an existing project. I'm going to BMP 280, which is a pre-existing project. Then we will work on your BMP 280 also. So by the end of this project, all you guys are converting your BMP 280 schematics into a PCB. So not everyone will not be working on the same BMP 280. For each and everyone we will assign uh, one particular project like a GY217. There are many. So this is the schematic diagram, right, of BMP 280. So here we have these two are the decoupling capacitors, and this is the these are the uh, since one terminal of them is connected to the positive power supply, we call them as the pull-up resistor. I told you there are two different types of resistor. One is the pull-up resistor and another one is pull-down resistor. So this is based on uh, whether the one terminal is connected to the positive terminal or the negative terminal. So if you keep a resistor just before the LED, we call it as the current limiting resistor, right? Based on the current limitation, we have a current limiting resistor, and there's another classification. For the data range, at least for the data transmission rails, if one terminal is connected to a data transmission bus and another rail is connected to positive terminal, we call it as the pull-up resistor, or else if it is connected to ground, we call it as the pull-down resistor. So now to open the layout manager, first you need to here you can find a PCB option, right? So you need to double click on the PCB option, then it will take you to the layout design window. So here you can find the PCB option, double click on it, it will take you to the layout designer window. So we will be working on, there are total two different aspects. This week we will be concentrating on the 2D thing, the entire 2D. So the next week we'll be focusing on 3D, but actually the 3D part is very low in ECEDA. The reason is that it's a web-based application. Here, everything, whenever you are placing a component, automatically it will take the 3D, 3D model also. But whereas in Altium Designer or any other higher advanced softwares, the 3D designing is also a little bit difficult, but here everything is automated, right? Yeah, so this is the layout design window. So first I'm just removing the parts. Okay, this is one of the part. This is an image. Okay, this is just an image. I'm just keeping it aside. So now can someone tell me, if I place this image over here, so what should be the layer under which this image should be classified? If I place this image on the top of a PCB, under which layer should this image to be classified?
Silk screen.
Under the silk screen layer, because I already told you, only labels, images, everything, whatever the things that you want to be printed on a PCB that do not carry any kind of electrical conductivity properties, they should be classified under the silk screen layer only. See, whenever I'm placing my cursor on the image, see, it is showing a pop-up, it's showing a tooltip menu, clearly indicating that it's a colorful image. And what is it showing? It is showing that top silk screen layer. And I told you silk screen layers are of two types, right? Top silk screen layer and the bottom silk screen layer. So top silk screen layer means if this image appearing on the upper surface of the, see, PCB is having two surfaces, right? One is the upper surface and the bottom surface. So based on the direction at which you are placing this image, so one surface is the top surface and another one is the bottom. So we are having obviously two different silk screen layers, top silk screen layer and the bottom silk screen layer. So you can have two different images also. So there is no such kind of restriction on number of images that you place in the silk screen layer. You can put as many as images as you want, but you should not go beyond the board outlines. So every PCB will have a dimension, right? Some specific length and some specific breadth. So you cannot go beyond that. Yeah, anyone having any question? Well, someone is trying to join the meet maybe. Yeah, Ibrahim, you have some question. Yeah.
Yes, sir. I said, what about us that are using the standard version of the ECEDA?
ECEDA?
Yes, sir. Because I'm using the standard version, not the pro version.
You are using the standard. We are actually using the pro version, not the standard one. Yeah, I think you might be in the standard version. Go back to ECEDA. Just visit the website pro.eceda.com. Don't go to the standard version. Go to the pro version. We are using the pro version. Maybe you are in the standard version. Therefore, the user interface and the options, everything would be little bit differ from what we are using right now. Is it
Okay,
clear?
how do I export my things to the pro version?
Can you
Like all my files.
can you just repeat the question?
How do I export my files from the standard version to the pro version?
Yeah, so actually there will be an export option in the standard for. Actually, the thing is like ECEDA right now do not support falling back from standard version to pro version. If you are in pro version, you can export it, you can turn it into a standard version. But if you are in the standard version, as of now, there's no way to import into the pro version, because the standard version we are having some simulation tools, whereas in the pro version simulation is not supported. The pro version do not support simulation, so therefore few components that you add in the standard mode, they may not be available in the pro version. So that's a conflicting thing. If you are already in the standard version, you can do the schematics, explore the functionality, you will be having an identical functionality over there, but the way where the options appear would little bit vary. Okay, so or else you can come back to pro version again, you can do the schematics there and you can perform it. Yeah. So right now we are in the layout design tool. So this is the layout design tool. So here there is something called a measuring tool. Okay. If you want to go to the measuring tool, first you need to go to tools and then click on measure. There are two different things: measure distance and measure object. Go with the measure distance. So if you want to measure the distance between two different points, let's say this is the point A and this is the point B. So if you want to measure the distance, you can measure it. It's not in a straight line path as of now, so you can measure it in whatever the inclination that you want. So this is something like a scale, measuring scale. Let's say I want to measure it from there to over here. You can measure it. It's something like around 11.557 or something like 11.430 mm. So now here we are having a properties menu on the right side. You can click on that. So here you will be finding two different parameters. One is the width parameter and another one is the height parameter. Basically, these width and height refers to the board dimension. Here you can change the dimensions of the board, the PCB. If whatever the PCB that you are designing, here you can put the width of the PCB and here the height of the PCB, the dimensions of the PCB. Here you can configure them. So now, if you want to place an image on the under the silk screen layer, first you need to go to the place menu, which is available in the top navigation bar. Then scroll down, you will find an option called image, and the shortcut key is like, first you need to press the letter P on your keyboard. Then this menu would appear on your screen. Then you need to press letter G on your keyboard. Immediately it will show you a file. It will ask you to select a file. Fine. So this is how you need to place an image, or else instead of shortcut, go to place, click on image. Here you can find the image option. So no sooner you pressed image option, immediately it will take you to the file manager or file explorer. Let's say I want to place something like a Suchana logo. So you need to navigate where that exact file is located in the directory. So let's say this is the Suchana logo. I'm just clicking on that. So then a menu will appear, so asking you, if you just click on confirm directly, this image will be converted into a grayscale image, black and white. Okay, so I already told you silk screen layers can be of two types, right? One is colorful silk screen layer and another one is the standard silk screen layer. So if you want a colorful silk screen layer, so what you need to do is like, here there's an option called place original image. There's a checkbox, place original image. So it is also indicated. Let me power up my laptop. So if you just click on that checkbox, colorful image would be inserted on the PCB. It will appear under the silk screen layer. If you do not tick the checkbox, then the image will be converted into a black and white or something like a grayscale format. Yeah. So you can decide whatever the way that you want. If you want a colorful silk screen layer, just click on this. And I already told you one more thing. There are many PCB manufacturers, right, across different countries. Like in China, we have a JLC PCB. There are many kinds of PCB manufacturers, right? Even in India, also we have a few manufacturers, Power PCB, or something like. Even Robo.in is also now involved in the manufacture of PCBs, right? So we are involved in designing of PCB for industrial standard. We have collaborated with the many PCB manufacturers across different countries, and we have been even at Suchana we have been delivering the products for customers since many years. So this is the option. JLC PCB is very famous for colorful silk screens. So no, sometimes the image may be a little bit simple and few images may be complicated. They are having a sophisticated geometry, right? So whenever they are printing the images on the PCB, they need to have the machinery and equipment which are having the high accuracy. So uh, different manufacturers are having different kinds of limitations to their machinery and equipment. Few are able to few can demonstrate high precision and accuracy. If you just observe the curves of the image, the edges, they will be very smooth for JLC PCB. So if I click on that, if I just enable this option, a colorful image will be added into the layout design. Or else if you do not click this, the image would be converted into black and white, something like a grayscale format. This will be inserted in the layout manager. So right now I'm going with a colorful silk screen. Here you can adjust the sizes also, but the aspect ratio will be the aspect ratio would be fixed. Right here you can change the dimensions also, the image dimension, or else the resolution. And here there are different units provided. You can give the dimensions in either mils or also. So once you are done with the dimensions and adding the image, click on confirm. As you can see, the image has been added, right? So it's a big image because we haven't changed the dimensions, right? See, this is the image. So later, even after adding the image, even if you want to change the dimensions, you are allowed to do that. There is no such restriction that the image dimension should be only configured during the insertion. There is no such kind of restriction. You are freely allowed to change, minimize, or else enlarge or diminish the image as well. So however, whatever that you want to do modifications, you are allowed to do that freely. There is no strict enforcement that the image dimension should be predefined. So see, I'm able to change the dimensions, right? You are free to do the modifications. You can adjust the size as per your convenience and requirement, and as per the available free space in the layout design. So now you have added an image, right? So now you need to make sure that this image is coming under the silk screen layer. So now here there's an option called layer. First you need to make sure that that you classify this image as under the silk screen layer. Only when if it is in the silk screen layer, then it will appear on the top of the PCB, because only the silk screen layer can show designators and symbols and all other text, symbols, images, everything for human readability purpose. They do not contain any kind of electrical conductivity properties. It is completely made with some non-conductive inks, okay, non-conductive resin, epoxy resin. So now click on layer. So if you want this image to appear on the top of the PCB, select top silk screen layer. If you want this image to be appeared on the bottom silk screen layer, then you go with the bottom silk screen layer. Basically we have two options, top silk screen layer and the bottom silk screen layer. If you want the image to be appeared on the top of the PCB, go with the top silk screen, or else if you want it to be displayed on the back side, then go with the bottom silk screen layer. So you are having two silk screen layer options over here, right? And there's an option called mirror. If you enable this button, the image would be mirrored. You will get a mirror image. You can set it to no. Here you can see, if you are changing the position, these coordinates will also change. So basically this is the x and y coordinate where the image is started. So like these are the coordinates of this particular point where the image is located, okay? So whenever you just move this image, immediately the coordinates, the x and y position in the no in the coordinate axis, they will change. As you just move, the values will get updated. So now if you want to rotate this image, let's say you want to rotate this image to 45 degrees, right? So you can do the rotation also. Here we have an option called rotation. So now I'm just putting 45. The image has been rotated to 45 degrees, right? From the origin. Here the origin refers to, I'm referring it to the origin of the image, not the origin of the entire coordinate system. I told you these x and y positions are exactly referring to the starting point. This is the point, okay? This is the point, the x value, the coordinate, the ordinate and abscissa, that means the x and y values, they are referring to this particular position where the image is started. This is the exact location of the image. So from that exact position, x and y, if you just draw an imaginary line over here, something like this is a straight line imaginary. So with that, it will make an angle of 45 degrees. So the image is rotating in the anti-clockwise direction, not the clockwise direction. If you want to rotate in the, uh, see now it rotated in the opposite direction, right? So now you need to give the minus value. So right now I'm just rotating it 45 degrees. Now I'm just inclining the image 45 degrees. Yeah, all set, right? So here you can rotate the image. First we learned how to add an image, right? So we already learned that image comes under the silk screen layer. Those who have attended all the sessions, those who are following the curriculum, they are very well about all these things. So images come under the silk screen layer. Now we have added an image. First we need to go to the place option. Then we need to select the image. So it will take you to the file manager or file explorer, and it will ask you to select an image. You can select the image. After selecting the image, it will show you a menu. A menu would hover on the screen, and in that menu there will be a checkbox, uh, uh, like place original image or not. So if you want to place original image, means refers to colorful silk screen layer, that the image is like colored. So if you by default, if you do not click on, if you do not enable the checkbox, it will be turned into a something like a grayscale image or else a black and white image, right? So if you enable that option, color, all the colors of the image would be intact. There is no change, or else there is no mutation in the color, or else alteration or conversion into any other kind of image format, downscaling to grayscale or black and white. There is no such kind of mutation. The image would be placed as it is, as if you upload it. Okay, no mutation in that. And there's an option also during the insertion only, there's an option also like to choose the dimensions or the resolution of the image. You can provide the units either in or mils. And then after you place the image, you need to make sure, like you need to configure whether you want the image to be appeared on the top silk screen layer, or on the, or on the, I mean, on the bottom layer or the bottom silk screen layer. So by clicking on that, properties will open. Here you can select the layer, either top silk screen or bottom silk screen, and you can modify the width and height also, either by modifying in the properties, or else you can simply use the drag and drop option. You can modify it with the drag and drop also. And then we also seen that how to rotate an image in clockwise direction and in the anti-clockwise direction. If you are giving the units in the clock, I mean in the positive radians, or else I mean the positive degree, then it will rotate in the anti-clockwise direction. If you give a negative value, something like a minus 45, then it will rotate in the another direction. So these are the basic operations of an image: how to place an image, rotation, classifying whether it's under the top silk screen or on the, or as if it's a bottom silk screen layer, changing its dimension, mirroring of an image. So these are the basic operations on an image. So up to here, you are having any kind of questions? Any questions till then? I hope everything is clear, right? We just learned how to place an image on the silk screen layer. That's it. Yeah. So now we will explore the other options in the layout manager as well. So finally, by the end of the curriculum, you should be able to design these kinds of PCB. Okay, now I will show you the 3D simulation as well. Don't worry, we have moved the images a little bit aside. Now we will again bring them back on the top of the PCB. See, this is the actual PCB. Now it's showing a little bit bigger one, right? Because we are having the images which are outside the board outline. Basically, this is the main PCB board. So this is the main PCB board. But the images that we have added are far beyond the board outlines, the dimensions of the PCB, the width and height. So that's why the PCB appears to be little bit big. So now I will be demonstrating you how the image that we added in a silk screen layer would reflect in a 3D visualization. So after discussing this thing, we can wrap up the today's session. So on tomorrow's session, we will be discussing how to do the routing, how to arrange the components in a symmetric fashion, different professional strategies and standards in layout designing, and then we will discuss about the different routing strategies. And after that session, followed by we have one more session where we'll be discussing about auto routing. So there are certain functionalities in ECEDA that will reduce your effort, make the things easy. There is something called auto routing. We'll be discussing in the upcoming sessions about routing and auto routing. So also we should not completely blindly rely on auto routing. It can do just like for AI we'll be having always a note that even Gemini can do mistakes, right? Similarly, auto routing can also do mistakes. So we need to be very careful. And despite you are using the auto routing tool, you must manually verify each and every connection, whether all are connecting in a proper way or not. We need to manually verify them. Okay. So now I'm just showing you. I would like to present how that image would appear in 3D visualization, the image that we added. So for this, I'm just connecting my external mouse to my PC. So now what I will do is, I'm just I will move the image, the Suchana logo, from outside the which is far beyond the board outlines to the top of the top of the area where we have designed the PCB. I mean under the area of the board outlines. Now I'm just trying to move that logo. Yeah. So I just connected my external mouse. Yeah. Now I'm just moving it on the top of the layout design. Okay. Now I'm just see, now the image is exceeding the board outlines, right? I'm just now trying to reduce the size of the image because it should not exceed the maximum board outline. So you can adjust it as per your convenience. Now I just kept it here in somewhere else in between. So now let me just verify if it is set to top silk screen. Now I'm just moving it to bottom silk screen layer. So today you all just practice how to place an image in a layout design window. Yeah. So now I'm just saving this and I'm going to 3D. So now still it is showing, it is not showing the image, right, in the 3D. If you just check the back side, so it is expected that it should display. Before that, let me at least delete this image for some time. Yeah. Now I'm going to 3D visualization again. So it is expected that the image should be displayed on the back side of the PCB, right? But it is not showing because you have set the silk here the silk screen technology, whenever you are using the 3D visualization option, so here there is a silk screen technology. You need to change it from standard to colorful silk screen technology. Then only you can find the image on the back side. See, this is the image. So actually we have already one more logo placed on the back side, so that's the reason. As you can see, there are two logos, right? So that's why two times it appeared. So now I'll do one thing. See, these are the images which we are having on the back side, the lead free, which we saw just a few minutes ago, right? See, even this is also part of a silk screen layer. Top silk screen, bottom silk screen. So now here there's an option called filter, right? And we are having a layer option also. Now you want to see only the silk screen layers, not the other layers. Then you can just uh, change the visibility of all the layers by clicking here. If you just click here, all layers will get the visibility state of the layers will change. Okay, not just a single layer. Here this option is applicable for all the layers also. It's already mentioned over there, all layers. So if you just click here, all layers will get disabled. I mean, the visibility will be hidden. Again, if you can toggle the state. No, first I'm just hiding everything from the visibility. Now I want to see only the top silk screen layer. So now if you want to see only the top silk screen layer, then go to the navigate to the top silk screen layer. Just click on eye option. So this is the top silk screen layer. So that means, sorry, this is the shoulder mask. This is the top silk screen layer. Yeah, see, this is the top silk screen layer. Got it? So now if you want to see the bottom silk screen layer where we are having an image, so this is the bottom side. So there are two, classified based on the top side and the bottom side, and the another one is others components 3D shell. So total we are having 5 sections in layer tool. So first what I did, I just I have changed the visibility state of all the layers. Then whatever the layer that I want to specifically focus on for troubleshooting or else for rechecking or validation, you can navigate to that specific layer. Let's say now I want to see the bottom silk screen layer. Go to that particular bottom silk screen layer and just click on the eye option and change the visibility. See, now you can adjust it. See, if all the layers are there at a time, it would be difficult for you to change the particular layer, right? See, now if I have all the layers at a time on the screen, so do you think it is very easy to adjust the image position, or else the other whatever that is present on the bottom side of the PCB? It's not that much easy, right? So if you try to click on particular component, it will see, I'm trying to click on the image, but see, it is clicking on the routing part. So that's why here whatever the layer that you want to adjust, you need to enable those particular layer and you can work on it effectively. If I want to adjust the bottom silk screen layer, I'm just changing the visibility of all other layers and I am enabling only the bottom silk screen layer. Now I can change it. Now I can increase or decrease the size of the image also. Here you can modify the text. We already learned how to modify the text, right? And here you can see a barcode. This is also an image placed with the help of place, and then going to G and then select barcode image. And then this is the lead free, which is also an image. So now one recommendation is that if you are working on silk screen layers, if you want to add some logo or else some kind of symbols, right? We are having some symbols like lead free, ROHS, uh, you know comply, some comply with the ROHS principles. So there are different kinds of regulations, right? um, so if you want to show those kinds of logos or anything, I request you kindly please add an PNG image. Okay, do not go with JPG or JPEG. You can add JPG or JPEG also. I'm requesting, it's a standard to add a PNG image. The reason is that in PNG image the background is like, there will be no background. You can remove the background also. There is a website called remove.bg. I'll show you. Before adding any logo, let's say if you want to add some Suchana logo, first go to remove.bg. In this remove.bg, click on upload image. See, this image is having a white color background. So this is having a white color background. Now I'm just clicking on that image. Now see the magic that will happen. It is changing the background image, right? It is changing the background white color. So that if there is no background, then whatever the surface, background surface on the top of it, if you put this image, it will immediately take the background of whatever the background that you already having, right? It can its background will be the same on which you are putting the on the top of it, which on top of it you are putting this image. The same background will be implied to this one. It will inherit the same. Simply it means that it is having no background on the top of it. If you another background, if you put this image, the same background will appear wherever there is no background. We are erasing the background pixels. So use this remove.bg before placing any images in the uh, uh, layout design, so that it will take the background, whatever the background we are already having, pre-existing background, it will take the same background, right? So that is the use of the remove.bg tool. So this is how you need to place the image. First, if you have any logo with you, make sure that the image is having at highest quality and the highest resolution. Because if the image that you are inserting is itself is at lower quality, then if they are during the manufacturing, they are having some limitations also for the machinery, so it may not be having the high accuracy. So if you yourself you are reducing the quality, then that would definitely it will affect the overall appearance. So from our end, we need to make sure that there is no chance for no chance for reducing the resolution of a silk screen. So if it's due to the hardware, I mean machinery limitations, that would be another part. But from a designer end, we need to make sure that everything is at the highest quality and standards, at the professional standards. Make sure that you whatever the asset that you want to add, whatever the media asset, I mean images, okay, not the videos are not supported. So whenever I just refer to media, it refers to images. Whenever we want to add any media asset, make sure that it is having a it is in the at the highest quality, highest resolution, and then go to remove.pg in remove.bg, and then remove the background. So after you remove the background, then insert the png image over here. Automatically, when you even though you having a jpeg image, when you remove the background, it will be turned into png format by remove.bg tool. And not only just remove.bg, there are multiple background remover tool, or else you can use a python code. You can do a python program which can remove the background pixels also using those image processing libraries. You can do that. So if you use remove.bg, there is a restriction that whenever you are downloading the image, so the quality will get reduced, the quality of the image will get reduced. So unless you are having a premium subscription, you cannot export at the higher resolution. So uh, if you want, you can go with the premium subscription. But or else, if you know python programming, there are multiple packages available, python image processing libraries, through which you can remove the background pixels as well. You can use those python program, and you can remove the pixels by yourself, and you can place finally you are having a final .png image which is having no background. You can go to place option on the top navigation bar, click on image, or else shortcut key G, and it will open the file explorer. There you can select the image. After selecting the image, it will ask you for the dimensions, and whether you want a colorful, whether you want to place the original image, or you want to by default it is unchecked. If you check it, then you can place a colorful image, or else it will be turned into something like a it will downscale the image into something like a black and white or grayscale format. So if you want a colorful silk screen layer, check the option, so that colorful silk screen layer would be applied. The image will be having there will be no mutation for the image. As it is, it will get placed in the layout manager. So then even after placing the image, you can modify the dimensions. But the first thing is, you need to choose the layer, whether you want it on the top silk screen, or else you want it on the bottom silk screen. And if you want to rotate it, you can do the rotation by going into properties, right? So these are the things that we need to understand. And we also learned how to focus on a particular layer in the entire we are having multiple layers, right? Top silk screen, bottom silk screen, shoulder mask layers, so assembly layers. We are having multiple layers, and some other miscellaneous layers will also be there, like a document layer, mechanical layer. We are having different layers, right? So if you want to focus on only a particular layer, you need to toggle the visibility state of all the layers first, and whatever the layer that you're working, that you wish to work on, so go navigate to that specific layer, and then enable, change the visibility from hidden to enable. So by that way you can focus on whatever the layer that you want. This is how you need, this is the entire operations behind image processing, placing an image, and changing its dimensions, everything. So basically these are the operations on image in ECVD. Any questions up to here before we wrap up the session? In the next two or three more minutes, I will be taking up questions from you. Then we can end up the session. And I hope our YouTube live stream is going on. Yeah, fine. Yeah. So any questions from your end till what we have discussed up to here? Yeah. What's your question?
Sorry, sir. Thanks very much for your impartation. Please, will the video of this class be available?
Yeah, the
Is it?
currently the session is being streamed in the YouTube. As soon as the session is over, we'll share you the live, I mean the recorded format of video which is available in the YouTube. From today, we are streaming
Okay.
the videos in YouTube. Unlike yesterday,
Okay.
the videos are uploaded in a Google Drive, which is a little bit a problem for us to handle, to record the session and regularly upload it to Google Drive. And the moderator is also a little bit unhealthy. So now all the sessions will be streamed in YouTube, and these will be shared as soon as the class is over.
Okay. Okay. Thank you, sir.
Yeah. Apart from this, anyone having any technical questions you would like to ask? Any uh, technical specifics?
Not yet.
Yeah. I hope the session is clear, right?
Absolutely.
Yeah. Yes. Inamal, I think you are having some question.
Yeah, actually yesterday we have completed the schematic, right? But today, after the schematic part, it is directly converted into PCB or we manually routing in a PCB section.
After the schematic,
It is automatically converted to PCB or we have to manually routing
no,
all
no,
the
no.
components.
Nothing happens automatically. We need to do some manual things also. Even if it happens automatically, uh, no, there would be multiple violations. So we need to do it manually. First, we are done with the schematics. Then you need to. There is an option called convert schematics to. First, we need to go to the PCB board. Then there will be option called convert schematics to PCB. So this thing we'll be discussing in the upcoming session. Yeah. Directly the schematics will not get turned into PCB. We need to convert the schematics into PCB, and then in the layout design tool we need to arrange the components uh, in an organized way, in a symmetric fashion, and we need to do the routing part. Of course, there is an auto routing tool. We should not completely rely upon auto routing. We need to do the manual routing, or else you can use the auto routing and do the manual verification. And then we need to perform the DRC check, design rule check, whether if we are violating any DRCs, or it's a DRC error free. If there's any DRC, we need to troubleshoot it. First, we need to figure out where the DRC error occurred, and we need to fix it. And then after this DRC validation, everything, then we will be automatically, whenever you click on 3D, you will get a 3D view of it. And moreover, you also need to decide the board dimensions, right? If you cannot directly jump from schematic to PCB. You need to choose the dimensions, right? See, if you just observe the previous PCB that I've shown you, there are border radius. For PCB, the edges are not sharp. We are having a border radius. So how we can change from sharp borders to border having a border radius? You can adjust the radius as per your convenience or as per your requirement. That thing we'll be seeing in the upcoming session. Yeah. Apart from this, any more questions, or shall I end the session? So those who understood today's concept can just raise your hand. I'll see who will. Rapidly, everyone. Those who understood today's concept, you can just raise your hand. I'm getting only eight hands raised. Rest there are 11 people, excluding me 10 people. And I'm sure Shikarani might be doing some other work, keeping the session active. I think so. So Sri Krishna, is today's session clear? Okay, fine. So you can lower your hands. So thank you for joining today's session. Signing off. This is Hemant from Suchana. Bye bye.